Today we're gonna move on. We're gonna be doing what we left off before the break, which is section 10.4, adding, subtracting, and multiplying radical expressions. The first three examples, well, the example one has three parts to it, and they're the easy ones. So here we're just adding or subtracting. So for this one, when you're adding and subtracting radicals, in order to connect the coefficients, in order to add the coefficients or subtract them, the radical needs to be exactly the same, meaning it needs to have the same radicand, which is the 11, and they need to have the same index, which is a 2 for this. Once you figure that out, once you know that they have the same radical expression, right, or radical, so 11, 11, 2, and 2, now you can combine the coefficients and numbers. So again, so for this it would just be 4 plus 8 would be 12 square root of 11. Square root of 11 cannot be simplified any further, so that would be the answer for that one. Same here. You guys notice this is before you subtract them, you need to see if the radicand is the same. 3x, 3x, it is. You need to see if the index is the same. 3 and 3, so it is. So that means you are able to subtract these coefficients. So 5 minus 7 would be negative 2 cube root of 3x. Right? Okay. Maybe here I should put it like that. So this is what happened, and then I just have this outside. So 5 minus 7 would be the negative 2. Here will be 4 plus 8. I'm just regrouping them, but that's what happened. 4 plus 8, 12. Square root of 11. This is, I'm just going to put it as a note. I don't want to confuse you. Alright. So for this one, you gotta look at the same thing. So do they have the same radicand? Yes, 5 and 5. Now look at the index. This one has a 3 cube, and that one has a square, so we can't, for this case, we can't combine. So that would be the answer. That's the answer. Can't combine any further. Let's move on to example 2. Now example 2, we're adding again and subtracting. The only difference is that now, remember before we left, we could break this into different pieces and find the square root. So you're finding the square root of 20 and the square root of 45. Right now, if you look at the radicand, they're not the same. They have the same index, but they don't have the same radicand, so we can't combine them. Can't combine the coefficients, the 1 here and the 2. So we gotta break these things out. We gotta factor them out. So this one, the 20 can be 4 times 5. Square root of 4 times 5. And this one can be 9 times 5. 9 times 5. So now the square root of 4, you guys know, is 2, and then the square root of 5 stays inside. Plus 2 times square root of 9 is 3 times, and then the square root of 5 stays inside. So that one stays the same. 2 times 3 is 6, square root of 5. Now let's check again. They have the same radicand and they have the same index. So now we are able to combine the coefficients. So 2 plus 6 gives you 8, and then the square root of 5. That's the answer. Now let's look at this one. So again, cube root of 54 cube root of 16 and cube root of 2. So that one we can't do anything about. But we can find a cube root of this one. We can break this into two numbers, factor. And one of them needs to be a perfect cube root. So I know that one can be, so let me do it like that, 27 times 2 gives you 54. And then we have the minus, and then we have the 5 times. This is cube. This would be 8 times 2, and then we have the plus cube root of 2. So I know the cube root of 27 is 3. 3, and then that one doesn't have, so it stays inside. Minus 5 times cube root of 8 would be 2. 2 times 2 times 2 gives you 8, so 2 outside, and then that 2 stays inside. And then that one is just that. So that one stays the same for now. 5 times 2 is 10. And then that one's just that. So now let's see if they have the same radicand and if they have the same index. They all have a 2 for the radicand. Good. And they all have the same index, 3, the roots. So that means we can combine the coefficients. So remember, when you don't see a number outside the radical, it's a 1. That's a 1. So you have 3 minus 10 will give you negative 7. Negative 7 plus 1 gives you negative 6. So this would give you negative 6 cube root of 2. I just added the coefficients. Maybe put a note here. So I did 3 minus 10 plus 1 cube root of 2. So 3 minus 10 plus 1 gives me negative 6. Okay. And that's that. Okay, C. So the same thing. So cube roots, we can't combine them because they have different radicands. They have the same index, but we can't combine this one. And this is a bit more difficult. So we're gonna break this one and this one. The book does it a little bit different, but I'm gonna do it this way because I like it. Ms. Benavia has a very good way too. So 48. 48 would be, let me think, and this is E, I don't know, I skipped this too. E would be 8 times 6. So 8 times 6, this one. And that one, we need to split them so that one of the exponents can be divided by 3. So that would be y3 times y1. 3 plus 1 is 4. 8 times 6 is 48. So now let's simplify this. The cube root of 8, you guys know it's 2, right? 2 times 2 times 2 gives you 8. And then 6 is going to stay inside. And then this one, remember, the exponent goes on top, the index goes on the bottom. So the 6 stays inside. There's no cube root of 6. The y to the 1 power stays inside also because there's no cube root of y. So this part would be 2, 3 over 3 would be 1, which is y. And then 3 is 6y. Okay, plus. Let's do this side now. So this one, the 6 can be split. There's nothing that we can find that would be a perfect cube root for 6. So that one we're going to leave it alone. But the 4 is just like this one. We can split it. So I'm going to do this. So the 6 stays. The y would be y again 3 and y to the 1. 3 plus 1 gives you that 4. Why am I doing 3 and 1, not 2 and 2? Because 3 is going to be divided by 3 and that's what we want. So again plus, so that one cube root of this one, remember this is 3 over 3. And then everything else stays inside. So the 6 stays inside and the y, there's no cube root of those. So this one becomes y 3 6y. Okay, now let's check if they have the same radicand. They do. Let's check if they have the same index. They do. So now let's add the coefficients. In this case they have letters, so 2y plus 1y gives you 3y. Don't get confused with those things. So if you have two y's and then you add another y, you just have 3y's. That's all you have to think about. So cube root of 6y, that would be the answer. Okay, let me do this one and I'll skip this one. So, no, actually I can do it because I want to show you that one. Let me do the D. So cube root of 98 and the square root of 98. So I know this one, this is the ones that you have to figure out. The perfect cubes would be 8, so 2 times 2, 8, 3 times 3 times 3, 27, and then 4 times 4, 16, times 4, so 16, 2, 4 times 4, 16 times 4, 64. And then after that, look guys, 5 times 5 times 5. I'm just giving you the perfect roots, cube roots. So these are some of the perfect cube roots. If you notice, 98 cannot be divided by 8 or 27. Absolutely not 64, 25. So 98 doesn't have a perfect cube root that you can split this one. There's nothing. You would have to be divided by 8 or 27, and it doesn't divide it by. So that one is going to stay the same. Now this one is square root. If you guys notice, this is cube, that's square root, so that's different. This is cube, perfect cubes, perfect cubes, so like that, with the 3. So we know this one gives you 2, that one gives you 3, that one gives you 4, that one gives you 5. So it doesn't have it. Now the perfect squares, square roots. So you know those are 4, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81. I think that I must stop there. So what do I mean? The perfect, if you take the square roots of these things, this one gives you 2, that one gives you 3, that one gives you 4, 5, 6, 7, 8, and 9. That's just some of those perfect squares, perfect cubes. This is just a note. Okay, so that one we can't divide by any of these, so we can't find a cube root. For that one, I noticed this one, 49. So this one can be split into 49 times 2. 49 times 2 gives you 98. And I know the square root of 49 is 7. So that one stays the same. Square root of 49 is 7, and then the square root of 2 doesn't have one, so it stays inside. So can we add these things? No, because they don't have the same radicand to start with, and they don't have the same index, so they don't have anything so that they stay like that. Now let's do C. So again, C, the letters of square root, and square root, they have the same index. They don't have the same radicand, so we need to split them. The x's is just to the first power, so we can't do nothing with those. So we're gonna split the numbers. So square root of, so these are the perfect square roots. So 27 can be divided by 9. 9 times 3, 27. So 9 times 3, 27, and then we have the x. Minus 2 times 9 is 3 times 3, right? And 9 is already a perfect square root, so I'm just going to leave it at 9. I'm just taking extra steps. 72 will be 36. So 36 times 2 gives you 72. 36 times 2 gives you 32. This is times. So now let's simplify. Square root of 9 is 3. The square root of 3 doesn't have any. It doesn't. So that stays inside the 3 and the x stays inside. So 2 times square root of 9 would be 3 again. And the x, there's no square root of x, so it stays inside. Plus square root of 36 is 6. And square root of 2x stays inside. So now let's see if we can subtract anything. To start with, they don't have the same radicand. They have the same index, but they don't have the same radicand. So what happens? They stay. I forgot to simplify this. 2 times 3 is 6. So on this example, they were trying to trick you because they have the same coefficient. But in order to combine them, the coefficient doesn't really matter. What matters is this radical. They have to have the same radicand. They don't. They have the same index, yes, but they don't have the same. So we can't combine these two, even though same over here, same different radicand, so we can't. So the answer for this one would just be this. Now let's move on. Sample 3. Okay. So now we're adding and subtracting, but now it's rational numbers, fractions. So there's different ways you can find the LCD, or you can just do the butterfly. For this example, I'm going to do the butterfly. 4 times 3, that one goes at the bottom, 12. 3 times that, so 3 times square root of 45 minus 4 times that, 4 times square root of 5. Okay. Now we need to see if we can find the square root of 45. When we can split this one and we can actually find something that does have the square root, that one stays the same. So I'm going to split this one, so I'm going to rewrite everything. I know that's going to be 9 times 5. 9 times 5 is 45. And I know 9 has a perfect square root. And then this side stays like that. So, and this one is outside. This is not the cube, but this is a coefficient. So the square root of 9 is 2, no 3, sorry. And then we have the square root of 5 inside, doesn't have a perfect square root. And this is 4 square root of 5. And put it on this side, it's not gonna fit. 3 times 3 is 9 square root of 5 minus 4 square root of 5 over 12. Now all you have to do is see if they have the same radicand. They do 5, the same index, yes. So that means you can combine coefficients. So the answer would be 9 minus 4 gives you 5. Square root of 5 over 12. And that's the answer. Okay, this one has an extra step. So If you see this part, I would separate the cube root individually with these two parts of this rational number. So I would do cube root of 7x over the cube root. This is a rule, you can do this. Cube root of 8 plus 2 cube root of 7x. And I would just put a 1 because that one's in a fraction. So cube root of 7x over cube root of 8, you know that's 2. 2 times 2 times 2 gives you 8. Plus, and then this. And this is where you can do either the LCD or you can do the, since we're not dealing with letters and monomials and stuff, this is a monomial, so I think we can do the butterfly easy. So I'm just gonna do this, and this. So 2 times 1 goes at the bottom, 2. 1 times that is just that. Plus 2 times 2 is 4, and then that. The cube root of 7x. Now look, they have the same radicand, they do, same index, yes. So remember this is a 1. So 1 plus 4, that means that would be 5 cube root of 7x over 2. And that's the answer for this one. So example 4, this is the last example. I'm gonna stop the video so that I don't make it that long. Thank you guys. I'll do this in a different video.